So in this example here, this is actually number 5D from section 3.3 in your textbook. And the question is now, how do we find all the factors for this given polynomial? This is degree 4, so there's going to be a lot of factors, okay? And we aren't given any hints as to what any of the factors are. In the above examples, we were asked if a certain binomial is a factor, and so we used a combination of the remainder theorem and the factor theorem to determine whether that was a factor. Now, we're not given any hints at all as to whether, as to what the factors are for this. We're asked to find all the factors. So the first thing that we need to talk about here is, how do you go about starting this kind of question? Like, what's the first thing you do? Do you just pick random binomials out of a hat, let's say x plus 5, and you find out if that's a factor? Like, you just pick one out of the hat and, well, almost, but not quite. So what you want to do in order to choose factors, because when you multiply, if you consider, if we had 3 or 4 factors here, and you were to multiply, probably at the end, you're going to be multiplying all of the numbers in the last, for the last terms of those factors, all the numbers are going to be multiplied to give you a constant, or multiplied and added to give you a constant. So this constant is the key in determining which factors you want to try to divide by, okay? And as a matter of fact, when you look at this constant, if there's a constant in the polynomial, which there always will be, either first step or second step, we'll talk about that later, but you look at the constant and you say, what are the factors of this constant? And those are the binomials that you're going to want to start with. For example, factors of 24 would be positive 1, negative 1, positive 2, negative 2, and so on, right? 3, 4, 6, 8, right? 12, and so on. So look at, because these are factors, what we're going to try is we're going to try this binomial, x plus 1. Then maybe if that doesn't work, we'll try x minus 1. If that doesn't work, we'll try x plus 2, and so on, okay? Now, it is important to note that the a value is what you're looking for. The a value. Okay, that's the one that has to be a factor of the constant. So the a value here is actually minus 1. The a value here is actually plus 1, right? Regardless, we're going to start with these factors. So I don't know what factors are factors or which aren't, but let's just test it out. So if I'm going to test x plus 1, what's my a value here again? A is negative 1. So let's try this. We put in negative 1 in for x. Okay, so take a moment to do that. And again, for this one, you may not need to write this all out, but I will just to explain. Okay, get rid of this here, it's in my way. And then minus 24. Okay, did I get that all written out right? All right, so p of negative 1 is, this is 1. That's going to be a negative when we take this to the power of 3, so that's minus 4. That's going to be a positive, so it's minus 7. That's going to be a positive, plus 34, minus 24. So we add all this up. What this is negative 3, this is negative 10. Plus 34 would be plus 24, minus 24. Oh, does it look like we have 0 here? Did I do that math correctly in my head? Are we good? Okay, so you guys agree? So we have a remainder of 0 for this factor. So guess what? This is a factor of this big, long polynomial. That's the first step. Okay? Identify one factor. Now that we've identified one factor, now you have to take the polynomial and you have to divide it by that factor to actually get the quotient. So what's left over? So you identify a factor and now you have to divide. So we can do that by synthetic division, can't we? Do you remember how to do synthetic division? Okay, so let's quickly set up synthetic division here using our factor that we've identified, x plus 1. I'll do that in blue. So again, negative 1 is our a value. Are these terms in descending order of x, and am I missing any x terms? So let's see, this is 4, 3, 2, 1, 0. It's all good. So let's put the coefficients, 1 would be the coefficient for this one. Let's put the coefficients along the top row there. And you should know how to do this synthetic division from the previous lesson. I always put a little box there so I can clearly identify what the constant is, or I'm sorry, what the remainder is. Okay, everybody with me so far? So now we divide. We know we should get a 0 here. We should. We've already tested that, right? So you're anticipating that should be 0. If that's not 0, we've done something wrong. Either we've misjudged this one or we've done something wrong here, okay? So this should be a 0, right? Let's go. Drop the 1. Multiply. Put the product there. Now we add. And that's one complete rotation. So now we go again. Multiply. Put the answer there. Add. Multiply. Positive 10. Put it there. Add. Multiply. Put the product there. Add. Excellent. We get 0. Does everyone see that? Does everyone see how that works out? So, now that we know a little something about synthetic division, I realize that I have x plus 1 as a factor. What is this quotient here now? That's going to be what? This was a 4, so this is going to be 1x cubed. That's a positive, so plus 3x squared. You just work your way down the degrees there. Minus 10x, and minus 24 is our constant. Does everyone agree with that? Everyone see how we did that? Oops, goodness. Okay, are we okay with that? All right, now you can work underneath here. I would suggest, no, we got to do this again, but I'm going to try and keep this all on one screen. So what I'm going to do is now we have to work on this polynomial right here. So guess what? We're going to try to pick another factor and then do the synthetic division. Okay? So let's get rid of this one and this one as well. And we have to now identify another factor. So, and it's for this one, right? So again, we could try minus 1, we could try positive 1, we could try 4 or 6 or 8 or anything like that. I tell you what, just to save time, let's try x plus 2. Okay? So again, you don't have to show all your work on these in determining, but you should at least try to show some communication that you're testing this one out. So a is negative 2. And so we're going to put negative 2 in for x in all these, right? Okay? So if we do that, negative 2 everywhere, what do we get? Negative 2 to the 4 is what? It's going to be positive 16. This is negative 2 cubed, so that's negative 8 times 4 is negative 32. All right, it's minus, that's 7 times 4 is 28. Am I double checking me here? I can hardly actually see here. That's 34 times negative 2, so that's plus what? 68 minus 24. I got that right? And so if we add all this up, then what do we get? Negative 50, negative 60, plus 68, that's 8. Plus 16 is 24, minus 24 is 0. Awesome. Okay? So you shouldn't have to try too many times before you get to a point where you could identify a second factor here. Yeah, question?
So you always do it to the original?
You always do it to the original. Yes, very good question. You always test the original. Well, actually, no, not always. You could test this one too. Yeah, I'm sorry. You could test either. And I guess because this one will be a little bit shorter, yeah. No, I'm sorry. You don't have to do the original. I guess I did there. But let's try it here real quick. So negative 2, right, plus 3 times negative 2 squared, minus 10 times negative 2, minus 24. Yeah, no, you know what? That's totally fine. Yeah, I don't know why I just gravitated to the back. Now, all of these factors will be factors of the original for sure, right? So, yeah, I guess maybe the reason why I went back to the original is because let's say somehow I've messed up on this. There's a chance. There's a chance that I've messed up somewhere. So if I go to this one that I've determined, now maybe I'm gonna really get something wrong if this is wrong. So now I've determined, oh, hey, this is not a factor because I screwed up here and I didn't realize it. So yeah, so you can go back to the beginning, but you can also go back to this one. So does this work then? This is negative 2 plus 12 minus 20 minus 24. Oh, sorry, cubed. That's plus negative 8. And okay, a little tough to see here, but yes, we get a 0 here, down here as well. So you can go either way. All right, so let's keep it moving. And what we're going to do is we're going to now synthetically divide here to see what our quotient is going to be. So we'll put negative 2 here. Okay, and we'll clean up all this. And we'll put our coefficients of this one right here. 1, 3, negative 10, and negative 24, right? Negative 24. And we should get a remainder of 0 as well. So it's a little bit off kilter there, but okay. So we drop the 1 down, multiply, add, multiply, add, multiply, add, 0. Boom. Got it. Okay? So you see how that synthetic division can start to get pretty quick, right? You could even go faster than that, and you see, hey, here we go, we've got a 0, and now I know what this is. So really what we've done here now is we've broken up this one into, so I have this factor still, right here. Now this one is broken up into x plus 2, so x plus 2 is now another factor I've determined, and what's left over? Well, let's see, this was cubed, right? So this is going to be 1x squared plus x minus 12. Everyone see that? So these coefficients go with this factor. And then, of course, you can factor this one now by sight, probably, right? Hopefully you can. Because what you'll get here now is x plus 1 times x plus 2, and then this one here, what two numbers multiplied to negative 12 add up to 1? That's x plus 4 and x minus 3. Does that look right? So we should have factors of x plus 1, x plus 2, x minus 3, x plus 4. Okay, so there's a couple ways you can check this. You don't have to multiply it all out. You could just do a quick check. If you multiply all of the first terms, if you multiply all these first terms, they should multiply to this very first term. Is that true? X times x times x times x, x fourth. Good. Then you can multiply all of the constant terms. 1 times 2 times 4 times negative 3. Does that multiply up to negative 24? Well, 1 times 2 is 2, times 4 is 8, times negative 3 is negative 24. There's a quick check. You see how that works? So that's our answer. Those are our answers. I'll just get rid of those circles, and we'll circle that up. And there is your fully factored form of our original p of x.